Good afternoon. We will continue our discussion on IC engine gas turbine, and in continuation of my discussion on nozzles, in fact which is used for the CI engine injection system. Today we will see that what are the important aspects for the SI engine injection system. And if we can recall that we have discussed about the carburation, in fact carburetor is an important part for the SI engine fuel injection, but we have discussed that carburetor is not used frequently nowadays because of several disadvantageous features, and of course modern carburetors, I mean if we modify the design, in fact carburetors are newly designed to improve their objectives, and I mean we can use carburetor, but today we will see that what are the important aspects which you need to consider for the SI engine injection system. And when we will be discussing about the SI engine injection system, again we will try to discuss that nozzles are also important for the SI engine injection system. So, to start with, today we will discuss about the SI engine injection system. And but before we go to discuss about the about different features of the SI engine injection system, we will try to recapitulate what we have learned from the carburation, and we will try to figure out what are the different problems associated with the carburation system, and because of those problems carburetor is not used nowadays except only of very small engines, but to rectify those problems, in fact nozzles are used to replace the carburetor. So, if we try to recall that for the carburation that we have discussed about, so and if we consider that I am not going to draw everything, but so this is the fuel supply line, and this there will be a air vent, and float will be, this float will be connected with the, and to maintain a constant level of, to maintain a fixed so say this height is small h, and this is section A and this is section BB. So, this is section BB and this is also section A. So, basically section AA pressure temperatures are, pressure is PA, PATM, temperature is TATM, atmospheric temperature, but section BB we need to know what is PB, we need to know what is TB, that is what we have discussed in detail when we have discussed about the mass flow rate of air and mass flow rate of fuel using this simple float type carburetor. Now, if we consider one thing, we need to note that the fuel flow will start only when there will be a drop in pressure at the venturi. So, airflow will start after the commencement of airflow. When air will approach the venturi, that is section BB, and when airflow approaches section BB, there will be a drop in pressure, and because of this drop in pressure, the driving force, which is again between these two sections, that is section A and section BB, will drive the liquid fuel to flow from float chamber to the venturi. So, this is venturi and this is float chamber. So, if we consider air to be an incompressible fluid, we can consider, because the PA and PA minus PB will be very small. So, we can apply P ATM by rho is equal to PB by rho plus CB square by 2, and from where we will get CB is equal to root of 2 into PA minus PB divided by rho. So, what we can see, then mass flow rate of air will be equal to m dot A will be equal to rho into AB into CB. So, that will be twice into rho into PA minus PB into CB under root into CB. So, what we can see, mass flow rate we can consider, because this is PA minus PB is very small. So, we can ignore the change in we need not to consider thermodynamics for this flow, but of course, we can consider, in that case we can consider air to be an incompressible fluid, and we can obtain the mass flow rate of air. What we can see, the mass flow rate of air is a function of PA minus PB, that is the drop in pressure. So, when we can consider this is also section AA, I can consider A prime, because the condition of air at AA prime is equal to the condition which is there in section AA. Now, what we can see, that the mass flow rate of air, which is definitely the function of the drop in pressure PA minus PB, and if we consider H, that is the height where fuel is injected, in that case fuel will be injected not only here, fuel will be injected over here. So, maybe fuel will be injected over here. So, if we consider H is very small, so this is section BB, and if we consider this height is very small H, so this is section BB and this is the height. So, if we consider H is very small, we get the the mass flow rate of fuel also will be we can obtain using this applying this equation. Now, question is, if we try to now recall the different zones of operation, that is what we have discussed in one of my last lecture, that if we try to recall, total engine operation can be divided into 3 different zones, that is fuel by air ratio, and if we try to recall, that is percentage opening of throttle valve, that is what we have written, percentage opening throttle valve. So, we can write that is nothing but PA minus PB. So, percentage opening of throttle valve, in a way indicates the drop in pressure that will be there. So, if we try to recall that the total engine operation can be divided into 3 different zones, that is so this is A, then B, then C, then D. So, A B, that is cruising zone, BC sorry AB, that is the idling zone, cruising zone, and CD is the power zone. That is we have that is what we have understood. Now, this PA minus PB, that is obtained by providing Venturi, and if we design a particular carburetor, the pressure drop we cannot change, this is fixed. So, if we design a particular I can say carburetor, and the drop in pressure at the section BB, that is at the Venturi, that will depend upon PA minus PB. Now, depending upon the magnitude of PA minus PB, the fuel flow rate will be determined. Now, question is for a particular fuel we know the density, surface tension, and also the height that level we need to the fuel needs to overcome the height difference. So, the PA minus PB, this is the driving force that is responsible for the flow of fuel from float chamber into the at the Venturi. Now, if we design a particular carburetor for a particular Venturi, diameter of the Venturi, diameter of the throat, this PA minus PB is fixed, and if we try to recall, this is nothing but stoichiometry. So, most of the time engine should run in the cruising zone at this stoichiometric air fuel ratio, this is stoichiometric. So, if we design a carburetor, what will happen? So, with increasing in this, so with an increase in pressure drop, now if we try to say, if we design a simple float type carburetor with an increase in delta P, the mass flow rate of fuel by mass flow rate of air will increase, right. So, what is seen that this flow rate, so if we design a particular float type carburetor for the given diameter of the Venturi, the pressure drop PA minus PB will be fixed. So, if we keep on changing, that means if we design the carburetor to supply the required amount of fuel air mixture for the idling zone, say we are designing the carburetor to supply, say these are the curves, say 1 prime, 2 prime, and 3 prime. So, if we design a simple float type carburetor to supply required amount of fuel air mixture, the amount of fuel air mixture which is required for the idling zone, what we can see from the schematic that now with a change in pressure drop, that is very important, because eventually need to increase the mass flow rate of fuel or mass flow rate of air for the power zone operation. What we can see, that means a simple float type carburetor which is designed to supply required amount of fuel air mixture, fuel air ratio for the idling zone, it will supply too rich mixture from the power zone. So, our objective is to supply the amount of fuel air mixture for the power zone that is here, but if we if we design to supply the required amount in the idling zone, we can see in the power zone the amount that will be supplied by the carburetor is I can say orders higher than what is needed for the power zone operation. Similarly, if we design the simple float type carburetor for the operation or for the supply of fuel amount of fuel air mixture required for the smooth operation during the power zone, in that case the carburetor will be able to supply required amount of fuel air mixture which is required for the idling operation. So, these are the problems associated with the simple fluid type carburetor, and because of this nowadays fluid carburetor is replaced by the SI engine injection system where nozzles are used. So, just I am writing here a few things that means if I can write that if a simple carburetor is designed to supply fuel air mixture for the satisfactory operation during idling zone, it would deliver far too rich mixture at high load. Similarly, if the carburetor is designed for the satisfactory operation under high load, right, the mixture at idling would be far too lean. So, these are the problems, because if we try to supply at high load, for the high load of course we need to increase the mass flow rate of fuel and air. If we try to increase that means we need to increase the pressure drop, then using the same carburetor it is very difficult to supply the desired amount which is required for the idling zone, and reverse is also true, that is what we have discussed now. Okay. So, we have seen that the simple fluid type carburetor is not an important, is not an important part for the SI engine injection system, where engine needs to operate at varying load, engine needs to operate in a condition when engine is attaining altitude and also other things, that is what we have discussed in the previous class. So, to overcome this, SI engine injection system nowadays are having different other parts, and that is what we need to know now. So, if we try to recall that SI engine injection system, which is of course we need to induct air through the intake manifold into the cylinder, then we also need to supply fuel, but instead of carburetor we will see that the fuel will be supplied through fuel nozzle into the engine cylinder, and now depending upon the position where fuel is sprayed, whether it is in the intake manifold, whether the fuel is sprayed inside the cylinder, the SI engine injection system is classified into different categories. So, we will know now what are the different classifications we can have for the SI engine injection system. So, I can write that SI engine injection system, rather I can write the advantages, right. So, advantages of fuel injection over the conventional carburetor that means number 1, I can write number 1, improved atomization, fuel is forced into the intake manifold under pressure, that is we need fuel pump which helps breaking of fuel droplets into fine mist. Number 2, that is smoother idle, that lean fuel air mixture can be supplied without rough idle because better fuel distribution and the low speed of atomization. So, this is smoother idle. Number 3, improved fuel economy. Why? Because more precise fuel metering, atomization, and distribution. Then number 4, increased engine power. Number 5, better fuel distribution. So, these are the advantageous features of the SI engine fuel injection system over the conventional carbureted system. So, now we will see what are the different types of SI engine injection system. What are the different types of injection system used for the SI engine, and then we will try to elaborate them with the schematic. So, now I am writing SI engine injection system, I can write classification. So, SI engine injection system classification. So, we have discussed about the advantageous feature, we have discussed about the problems associated with the carbureted system. Although we have discussed about the deficiencies of the simple carburetor, but today we have discussed about the real problem associated with the simple fluid type carburetor. Then we have discussed about the SI engine injection system, that the injection system, that means we should have fuel pump and fuel nozzle, and using fuel pump and fuel nozzle, if we spray fuel into the engine cylinder, now this system will have of course a few advantageous feature over the conventional carbureted system, that is what we have listed down in the previous slide. So, we have seen that the fuel injection system is important, and now depending upon the location in which the fuel is sprayed, whether it is sprayed into the into the engine cylinder or fuel is sprayed in the intake manifold, the SI engine injection system can be classified into a few categories. And so, we are writing now. Number 1 is it can be classified depending on the injection mode. So, that is injection mode, and this can be further classified into two categories. Number 1 is direct injection type, then port injection type, and then it can be classified whether it is single point or sometimes known as throttle body injection. Number 2, that is very important for the modern engines, that is multi point fuel injection, that is MPFI, and finally that is the types of actuation, that is either mechanically actuation, hydraulically, and last one is very important, that electronically controlled. Unit, that is ECU in short. So, we will see now that with the schematic depiction we will try to explain the injection process, but before that we have classified that the SI engine injection system can be categorized based on the injection mode, and under this category we can further subclassify into two different categories, that is direct injection type and port injection type. Then whether it is single point, that is number of injection nozzle, number of point through which fuel is injected into the cylinder or into the intake manifold, that is single point, that means. So, this is basically number of points, and also multi point fuel injection, that is very common nowadays, MPFI, and finally the types of actuation, that is whether it is mechanically actuated we will see or it is hydraulically actuated, and finally which is very common for the modern engines, that is the electronically control unit. So, we will now discuss one by one, that is direct type. Direct type fuel is directly fed into the cylinder, right. So, fuel is directly fed into the cylinder. We can draw the schematic. this is bottom dead center, this is top dead center, this is exhaust manifold, this is intake manifold. So, we will have a throttle valve like this, throttle valve. So, this is throttle valve and fuel is fed through the nozzle directly into the engine cylinder. That is what we have discussed in the last class in the context of CI engine nozzles. So, this is the direct type. Now, if it is port type, that is fuel is admitted, so that is direct type. Then if it is port type, port injection, what is done? Just I am drawing the schematic again. So, this is top dead center, this is bottom dead center, and this is the valve, this is the piston, and which is having reciprocating motion. Now, this is the throttle valve. So, this is the throttle valve, and in this port type. So, this is for the direct type, and port type fuel is admitted into the intake manifold instead of So, this is the port type, and fuel is, so we have fuel nozzle over here, and fuel is supplied upstream of the throttle valve. So, this is the this is nozzle. So, this is also nozzle. We have discussed about the requirement of nozzle and what are the different objective we need to consider while we are designing nozzle in the last class. So, what is done for the port type? Fuel is port type, that is fuel is admitted into the intake manifold, that is not directly into the engine cylinder. So, this is port type. Next is, so that means if we try to classify injection mode, that is whether it is directly fuel is supplied directly into the engine cylinder, that is the direct type, but in case of a port injection type, fuel is supplied into the intake manifold just upstream of the throttle valve, and this is of course, we should discuss, I mean maybe this is not included in the content of this particular in the syllabus of this particular course, but if we get time we will discuss why the port type is important and when you need to have port type fuel injection system for the SI engines. I mean maybe if we get time towards the later stage of this course. So, next is the that is known as depending upon the number of nozzles, number of points through which fuel is supplied or fuel is sprayed into the cylinder or into the intake manifold, it is single point, or throttle body. Single point or throttle body. That means what is done, So, this is top dead center, this is bottom dead center, and this is multi-cylinder engines. This is common flywheel. Now, what is done? We will have throttle valve. So, this is throttle valve and fuel is supplied upstream of the throttle valve. So, this is fuel is supplied. So, this is nozzle, right. Now, this is known as single point or throttle body. So, fuel is sprayed upstream of into the intake manifold. It is what the schematic is for the multi-cylinder engine. Now, and the supplied fuel and air which is taken, I mean the supplied fuel and the air which is coming through intake manifold is taken into multiple cylinder depending upon the requirement, of course. Now, we need to know what is multiple point or throttle body injection. So, this is single point or injection system or throttle body injection system, sometimes known as TBI, that is throttle body injection system, and these are single point injection system or multiple point fuel injection system. These are electronically controlled injection system in which a centrally located solenoid operated injection valve which controls the sprays of the fuel and all those things. The single, I am writing the single point injection system has the same air and fuel mixing distribution problem as a carburetor. So, the single point injection system has the same air fuel mixing distribution problem as a carburetor. So, what are the problems? Maybe this issue we did not discuss. When air fuel mixture, a common intake manifold is there and the air fuel mixture is supplied into multiple cylinder, there is a basic problem. What is the problem? So, fuel is supplied, fuel is sprayed and the fuel is mixed with the air and that air fuel mixture is supplied. Now, it is very difficult to maintain that the supplied fuel will have, the fuel is not a particular hydrocarbon, rather it is family of hydrocarbon. So, the larger hydrocarbon will try to follow the what I can say, they will try to remain stick near the wall, they will try to follow the in the straight path, and the smaller hydrocarbon that will try to follow that they will try to follow the central core region and they will enter like this, while the heavier hydrocarbons will try to follow the path close to the walls or solid boundaries. So, because of this what will happen, we will have distribution problems. So, there will be an uneven distribution of the air fuel mixture into the into different cylinders. So, this problem is there even for the carburation carbureted system, but if we talk about single point or throttle body injection, even then although we are having a fuel nozzle which is used to supply fuel upstream of the throttle valve, but the distribution problem will be there, and to avoid that, now to circumvent this problem, the multiple point fuel injection system came into the picture. So, next we will discuss about the multiple point fuel injection system. So, this is multiple point fuel injection system. So, this is also known as MPFI. What is done? So, if we try to go back to the previous slide, we can see we have only one nozzle which is controlled by centrally operated solenoid valve upstream of the throttle valve, but and the single nozzle is used to supply the required amount of air fuel mixture for all the cylinders. But question is, we have seen that fuel is not a single hydrocarbon, rather family of hydrocarbon. So, although we are supplying fuel through nozzle, it is very difficult to say that the all fuel will be fragmented into smaller and smaller particle. There will be heavier hydrocarbons and lighter hydrocarbon. Heavier hydrocarbon will try to follow the path which is close to the solid boundary, while lighter hydrocarbon will follow the path of the central region, for which and because of this there will be an uneven distribution of the air fuel mixture. That cylinder which is very close to this nozzle and this throttle valve will get the amount which is not equal to the amount which is being fed into the cylinder which is furthest away from the fuel nozzle. So, this distribution problem is there, and also the mixing this distribution problem is similar to what we have seen for the carburetion system. But for the multiple fuel injection system, each cylinder has its own injector, and I can draw the schematic. So, if we try to draw the multiple point fuel injection system, so then so we will have throttle valve. So, this is throttle valve, this is air, and there will be fuel injection system here, here, here. So, I am writing A, B and C. So, this A, comma B, comma C are the fuel injector. So, that is each cylinder has its own injection system, rather I can say injector discharging fuel into the area directly. So, these are the intake valve, these are the intake valve. So, I can maybe I don't want to show the intake valve over here. So, directly into the area directly in front of the intake valve. directly in front of the intake valve. So, this advantage is that instead of a single fuel injector, the multiple point, that means we have fuel injector at multiple points and each cylinder has its own injector which is used to supply, which is used to discharge fuel into the area which is in front of the intake valve. Now, and if I try to draw this, just if I try to draw this, it will be like this. And fuel is supplied here. Fuel is supplied, I can write fuel is supplied here in front of the intake manifold. So, this is nozzle, right. So, this is the multiple point injection system. This system is having of course advantageous feature over the single point fuel injection system, and this system is also known as, this system is also called as port fuel injection system, and these are also the indirect injection system. So, this is also called port fuel injection system. Now, so fuel is injected directly in front of the intake valve. So, this is done purposefully. What is the purpose? Purpose is that contact of fuel with the relatively hot intake valve. So, hot intake valve, so when engine is running, so when engine is running, then I will discuss the combustion of SI and CI engine, then we will come to know that as the engine is continuously running, with time the intake temperature of the zone, temperature in the zone of intake valve will be higher. So, I mean rather I can say the temperature of the intake valve will be higher. Now, when you are injecting fuel in front of the intake valve, that means we are injecting fuel in a zone where temperature is relatively higher, and that hot intake valve, rather hot areas, hot spot rather I can say, we will try to enhance the evaporation of the fuel droplet being spread. So, that means the fuel is purposefully injected in front of the intake manifold. Why? Because the engine is continuously running and the intake manifold will, after certain time of operation, intake manifold temperature will be increased, not only the intake valve temperature, but the zone close to the intake valve will have higher temperature, and the moment when fuel is sprayed into that zone where temperature is higher, so that hot spot will enhance the evaporation of the fuel droplet which is being supplied into that zone. So, that is why the fuel nozzle is equipped in such a way that it is injecting fuel, it is discharging fuel directly into the directly in front of the intake valve. So, this is the multiple point of fuel injection system, and then we need to discuss about two other class, that is types of actuation, that is mechanically actuated and the hydraulically actuated. And of course, Finally, we need to know what is electronically control unit. That is very important, because electronically control unit we will see in a today, that depending upon the sensing the pressure temperature of the intake manifold, the amount of fuel and amount of air that is being supplied into the engine can be controlled, and that is why it is known as electronically controlled. And we also will see that using the mechanically operated system, of course, we need to we need to supply electrical energy for the excitation of the solenoid valve, but still we will see that by mechanically operated system, we can also control the amount of fuel and air that is being supplied into the intake manifold, and that systems are used nowadays for the SI engine injection system. So, with this I stop my discussion today, and we will continue our discussion next class. Thank you.